Let us now consider the next problem of using arrays. Here we will learn about another important way to use the array. An array is a useful tool in processing similar data uniformly, but there are other important ways of using this. Let us take a look at such an example by thinking through the next problem in this exercise. The problem is to calculate 1 divided by d. It takes the value of d and continues on to display the decimal values on and on, such as 0. Blah blah blah. Well, as you know, it may be the case where this continues infinitely by recurring when 1 divided by d is a recurring decimal. I will give you a program for this computation, and the problem is to modify the program so that it terminates its computation when the recurring starts. Here is the original program. Let's name it divloop.rb. It runs like this. Let's see this example closely. When you run this divloop.rb, it requests for the denominator d. In this example, we enter 4. And then it will calculate 1 divided by 4. Let's compare this computation with our usual calculation. We write like this. The quotient starts with the point, or 0 point, because 1 is smaller than 4. Then the first number of the quotient after the decimal point is 2, computed like this by dividing 10 by 4. Also, as a remainder, we have number 2 below. The computer just gives this information like this, 10 divided by 4. Quotient 2 is here, remainder 2 is here. Next, this remainder is multiplied by 10 and then divided by 4, yielding quotient 5. And in this case, null remainder. Again, the computer outputs like this for this division. Now, no remainder is left, so the computation terminates. This is what the program divloop.rb does. So by going through the first numbers, we know the answer of this division is 0.25. Consider another example. This time we input 7 for d, so the task is to divide 1 by 7. Well, we calculate in this way. Again, let's see how the computer outputs following this calculation. First, 1 is multiplied by 10, and then it is divided by 7. Then it's a result. That is, quotient is 1, and the remainder is 3, is given as an output. Next, this remainder is multiplied by 10, and then it is divided by 7. And this yields the quotient 4 and the remainder 2. Well, the calculation goes on similarly, like this. Note here, we again have 10 because the previous remainder is 1. Then calculation comes back to the same situation, right? The same situation compared with the beginning. Then it will repeat the same thing again. That is, recurring occurs and the computation will continue forever. We would like to stop around here. This is the requirement that our problem asks for us. Now let's go back to the original program and how it computes as we have seen. First, this is a port for getting the input. That is the denominator d. The first line is for showing the message on the screen. So when executing this program, this first line is executed and then this message is shown. The second line, this one, is for getting the input and then storing it to the variable d. For example, by typing 4 here, the number 4 is stored into the variable d, which is used as the divisor. Then the third line is for showing this message. Well, this is not the correct way to write the print command, but let me explain this later. And here, please assume that this message is like this is shown on the screen at this point. The main computation is done in this part. Here, there are two important variables. The variable x is used to keep the remainder that is just obtained, which is in fact the next dividend. So initially, it is set to 1 here because we are going to compute 1 divided by d. The variable stop is used to remember the status of whether the calculation should be stopped or not. We use its value to determine whether the while loop repeats the next round. More specifically, we use the variable stop here in the condition of the while loop. Recall that this exclamation mark and equal sign means not equal. So this condition means that the next round is executed if the value of stop, this variable stop, is not 1. Otherwise, if it is 1, then this while loop is terminated, which is in fact the end of the program, end of the computation. So initially, we set the variable stop 0. Let us continue this execution example and then trace the computation of this blue part. In this execution, we want to compute 1 over d, that is 1 divided by 4. So let's start this blue part with x is equal to 1 and stop is equal to 0. First, check this while condition. Because the value of stop is 0 now, and then it is not equal to 1, so this condition holds. So we execute the first round of this while loop. First, the value of x is multiplied by 10, which is the actual dividend. Then, in the second line, the quotient x divided by d is computed and stored into the variable q, which corresponds to this calculation. Then here, the remainder of this division is computed and stored into the variable x as a new remainder. This corresponds to this calculation. Then, by this print command, the value of q and x are displayed like this. Again, let me explain later on the exact way to write this print command. Now, in this if statement, that is, in these 3 lines, we check first whether the new remainder is 0 or not. If it is 0, then set 1 to the variable stop to terminate the while loop. Here, since x, the current remainder, is 2, so this line is not executed, and then value of stop is still 0. Then, since this is the end of the body of the while loop, the computation goes back to the starting point of this while loop and checks this while loop condition. Again, since stop is still 0, the condition holds and the next round is executed. Then the computation corresponding to this calculation is done, obtaining 5 for the quotient and then 0 for remainder to the variable x. And then by this print command, these values are shown on the screen. Then consider this if statement. Note that this time the remainder is 0, that is, the value of x is 0, so the condition of this if statement holds, and then this line is executed, then the value of stop becomes 1. Now, going back to this line to check this condition, then this time the value of stop is actually 1. That means that the condition is failed, and so the while loop is terminated, and then since there is no command after this while loop, this is the end of the computation, and then the program terminates like this. By the way, using a variable like this stop is typical programming technique you had better remember. As you see, we know that the calculation is over as soon as we get a null remainder. On the other hand, the decision of whether the next loop round is executed or not is made at the top of the while loop. So we introduced the variable stop to remember the change of the status. We would often call this role of the variable as flag. The variable stop is used as a flag, the flag for the stopping condition. Whenever we know the while loop should be terminated after this round, for example at this point, then the flag becomes on, that is the value of variable stop is set to 1. We write a program assuming this role of the variable stop. Then what we need is here is to check at the beginning of the while loop is to check whether the flag is on or off. That is whether the stop is 1 or not. And then if it is 1, then while loop is terminated, whereas if it is not, the next round is repeated. Although this is a simple technique, it is quite useful and then often used in programming. Now consider the case where we give 7 for the denominator. That is, the division of 1 by 7 is computed. Then, as we discussed, the computation goes like this, producing the recurring decimal forever. What we want is to modify the program so that the computation is stopped around this point. So the question here is, as you get into this infinite loop, how do you stop this? Here is a hint. As we have seen, the recurring can be detected when the same remainder appears. If so, we only have to set the variable stop to 1, meaning to terminate the while loop. Then how can we find that the same remainder appears? This is the case where we can make use of an array. Here is another hint. Why don't we use the array T consisting of D boxes, each of which is assigned 0 initially? Recall that D is the divisor, and note that the range of remainders is from 0 to D minus 1. That is D possibilities. We can use these D boxes of the array T to check whether the same remainder had appeared before. Let's think about it on the actual program. Finally, before moving to the actual programming, let me explain briefly about the print command. Well, this is just a sidetrack type explanation, so you can skip it for now. Anyway, let me explain a bit. In this program, we are using 2 print commands. One is for showing this message. Another is for displaying the result of the computation like this. Recall that we use the puts command for showing some message on the monitor. The print command is another way to output what we want on the monitor screen. By the print command, we can control the output in various ways. One of its useful features is that there is no automatic line break unless it is explicitly stated. Actually, these are not a correct way to write print command. This one is a write print command. It orders the computer to display 3 strings. The first one is find 1 slash. The second one is the value of the variable D. And the third one is this \n. This last \n means the line break code. Showing this code on the monitor means to make the line break. Please note that this \ symbol is shown like this in Japan. This is a Japanese yen mark. So please allow me to use this Japanese yen mark in this course for the \ key. The location of the \ key depends on the computer. Similarly, this print command should be written this way. This means to display 4 strings. The first one is the value of the variable q. The second one is comma and space. The third one is the variable x, and the last one is again the line break. Note here that we need to state what we want to display explicitly, even a comma or the space. This was just a sidetrack explanation. All you need to get now is that this is how you write such print commands. Now let's move on to the actual programming.